want to remind you guys about some trig that I'm sure you knew once. I'm not sure if you still remember it. Okay? And we are going to use trig a lot, but we're only mostly going to use right triangle trigonometry. Okay? Now, the reason we have to use trigonometry is because we're moving into two dimensions. And if I have a force that's acting in more than one dimension, I can't call this positive or negative anymore. Because not only do I have parts of it that are moving to the right, I also have parts of it that are moving up. And similarly, if I had another force that was moving like in this direction, or a motion that was in that direction, then I have it's negative to the left, but it's positive in the vertical direction. So in two dimensions, we can't just use positive and negative anymore. When we get into two dimensions, we actually have to start doing some trigonometry. And I'm sure you guys remember how to do trig with sine, cosine, and tangent, right? First thing I need is a right triangle. Okay? And a lot of times the hardest part of what we do is going to be finding the right triangle to make what we need to happen. Okay? So here's a right triangle, and you can draw it in any orientation, it doesn't matter, and you can pick whatever angle you want. This is the standard way to do it. Okay? So this is the Greek letter theta, and theta is generally the symbol that we use for angle in both math and science. Now, the other sides need names. This is the x side, but that's only because it's in the x direction. It's the adjacent side. Okay? This is the side that's closest to or adjacent to the angle. This is my y side, but really it's in the y direction, but it's the opposite side because it's the side opposite the angle. And then this doesn't have any x or y because it's both. This is the hypotenuse, right? It's the hypotenuse of a right triangle. Now, if you guys recall, and there's the mnemonic device, right? SOHCAHTOA, which says that the sine of the angle, the sine, right, which we usually abbreviate SIN, sine of the angle, sine of theta, is equal to the opposite side over the hypotenuse. So I'm going to say the sine of theta is equal to y over h. And then we have the cosine of theta, right? Cosine, we usually just abbreviate COS, is equal to the adjacent side, x, over h. And then tangent is actually a combination of both of those things. The tangent, which we abbreviate tan, the tangent of the angle ignores the hypotenuse and it just uses opposite over adjacent, which in this case would be y over x. Now, this is the standard orientation of a triangle, but it doesn't have to be. You could put your angle up here, okay, and this would be a different angle. I call it phi, and then that would change what my sine, cosine, and tangent were. So you have to pay attention still to your frame of reference, or what your reference point is. Okay? So that's trig, right? Sine, cosine, and tangent. Let's throw a couple numbers in here and make sure we know what we're doing. And then let's also reverse it. Okay? So the first thing I want to do is let's just solve a right triangle. Solving right triangles is easy. That means find the angles and find the lengths of the side. Given enough information, find the rest of it. So here's a right triangle, and let's say that this side down here is 5, and this angle right here is 28 degrees. Okay? And I want to know the other two sides of this triangle. I have a variety of tools that I can use to do that. One of them is the fact that if this is a 90-degree angle, it is, and this is 28, remember that there's 180 degrees in one triangle. So 90 plus 28 gets me to 108, which leaves me with 72. Okay, so I know this is a 72-degree angle. Whoops, I'm pretty sure I just did my subtraction wrong. That's a 62-degree angle. So we'll change that. That's a 62-degree angle. Now, I've got my two angles, which is good, but I still need to get my sides. And we could use the Pythagorean Theorem, which says a squared plus b squared equals c squared, where one of the sides is a and one of the other sides is b, and the other side, the hypotenuse, is c, but I don't know two of the sides. So I'm going to use trig, and since I know an adjacent side, I can either use cosine or I can use tangent. So if I grab my marker, let's see, I've got the cosine of 28 degrees is equal to the adjacent side, 5, over the hypotenuse, h, whatever it is. So if I solve this for h, I have h is equal to 5 divided by the cosine of 28. Now, depending on your calculator, you're going to put this in a little bit differently, but most scientific calculators, you're going to push cosine first. So when I take 5 divided by the cosine of 28, I end up with a number 5.663. And I should stop and think to myself, does that make sense? It's bigger than 5. Well, the hypotenuse is always the bigger of the three sides of a triangle, so yeah, that's good. So I can say this is 5.663. And if I want, now I can get the other side either with the Pythagorean Theorem, or I can use sine. I could say the sine of 28 degrees is equal to the opposite side, y, whatever, over this 5.66 I used. Or I could even use tangent, and I could say the tangent of 28 degrees is equal to the opposite side, y, over, right, I'm calling this y, the adjacent side, 5. And if I do that, then 5 times the tangent of 28 degrees will give me my answer. So 5 tangent 28 is 2.66. Okay. And again, I should stop to make sure that this answer makes sense. Well, this is clearly the shortest of the three sides. It's across from the smallest angle. Yes, that answer does make sense. Okay. So solving a right triangle is a pretty simple thing. Remember, if you're given a number and you need to find an angle, so let's say this angle is theta, and this is my 90 down here, and this is 8, and this is 4. Okay, then, well, yeah, alright, that's 8, this is 4. Then, what is my angle? Well, since I know an adjacent side and I know the hypotenuse, I'm going to say the cosine of this angle is equal to the adjacent side, 4, divided by the hypotenuse, 8. Now, I'm looking for this, I don't know it, so I actually have to do the inverse of cosine, which on your calculator is cosine to the negative 1. And if I take cosine to the negative 1 of the cosine of theta, what I do to one side I have to do to the other, that's cosine to the negative 1 of 4 over 8. Well, the inverse function applied to the function cancels that, and I'm left with theta is equal to the inverse cosine, and on a calculator that's usually the second cosine function. 4 divided by 8 is 60. Okay? So the inverse cosine or arc cosine is 60 degrees. So it's a pretty straightforward process.